All right, 13.1. You're not going to have to learn how to do derivatives anymore, but you are going to be using the derivatives. Okay, let me make this a little bit bigger. And you can't see this very well right now, but if you're looking at it on your computer, when you look at the notes or you look at the video, this is going to give you the tests for where f of x is increasing and decreasing. Back before there were graphing calculators, and I know you can't even imagine, but back when I was in school, no calculators. I mean, none. And to talk about functions and what they did, you had to use the derivatives to do some of that. Like if you knew you had the function and you wanted to figure out what it looked like, instead of trying to graph it by hand, if you found the derivative and found out where the derivative was positive and negative, that's going to tell you where this thing's increasing and decreasing. Well, we're going to learn that process now, okay? So, a couple of things. Here's the test. It says if f prime of x is greater than 0, that means positive. So where the first derivative, and don't try, Julie, don't try to worry about writing that down because you're gonna get it, and it's too little. But where the first derivative is positive, the original function's increasing. Where the first derivative is negative, the original function is decreasing. Okay, that's what we need to remember. Critical numbers. Critical numbers are those numbers where either the derivative equals 0 or the derivative doesn't exist. So those are critical numbers, and we're going to be finding those. We're going to find the derivative, we're going to set it equal to 0, we're going to get a critical number. Okay, so we will do that. So here's what you'll do. You will get the critical number. We're going to make a little chart, and we're going to define intervals. And all this will make sense when we start doing it, or at least that's the hope. Then we're going to test a value in each interval. Do you guys that have had calculus, do you remember that when we did that?
Oh, yeah.
Oh, Liz. Okay. And then we're going to determine the increase and decrease. So let's look at an example. This you might want to look at. All right, here's the original problem. And it says, where is this thing in blue increasing and decreasing? It's a cubic function, so it is going to have some turns. It's like a drain pipe. Okay? First thing you do, find the derivative. So that's what I've done here. 3x squared plus 6x minus 9. Take the derivative and set it equal to 0. That's what I did in the next part. Sometimes you'll be able to factor it real easily. Sometimes you might take a little bit of work, but for the most part, it shouldn't be too difficult. So I did that, and I came up with -3 and +1. Those are the critical numbers. So what have we done so far? We took the derivative, we set it equal to 0, we solved for x, and we got our critical numbers. Okay? Everybody good with that? I'm going to move up a little bit. So this is the kind of line you'll draw. You'll draw a straight line, and however many critical numbers, you'll draw a vertical line for each of those. Let me make that a little bit bigger. So straight line, vertical line for x equals 1, vertical line for x equals -3. Okay? Then you define the intervals. Okay? If think about being on the x-axis. If I'm on the x-axis and I'm coming up and I hit x equals -3, well, everything to the left of that is -infinity, right? I mean, if I go all the way, I'll never reach it. So this interval is from -infinity all the way up to -3. Inside here, what's the boundaries? -3 and 1. So this interval is -3, 1. And on this side, what's the interval? 1 to infinity. So you'll define the intervals. If you have 4 critical numbers, you'd have a lot of intervals. If you have 1 critical number, you'll have 2 intervals. Whatever it is, you define the interval. Okay? Then you're going to pick a value that's in that interval. Now, Taylor might pick -7. Liz might pick -2. Well, she can't pick -2, but she might. -10. it doesn't matter. You're going to get the same type answer because you're not worried about what number you get. You're worried about the sign that you get. So I picked -4 because that's on this side. Here, between -1, I picked 0. Between -3 and 1, I picked 0. Always pick 0 if it's in the interval because it's easy to plug in. Over here, I picked something greater than 1. I picked 2. And remind yourself that you are testing the first derivative. So I write f prime, f prime, f prime. Because where do I plug that in? I don't plug it in the original. I plug it in the derivative. So when you plug that in, what I'm interested in, do I get a positive number or a negative number? I get positive, and you could test that. You go right here. Where was our derivative? Here's our derivative. Or you could use this one. If you plug in -4, you get a positive 16, minus 8 would be 8, minus 3 would be 5. So it's still positive. That's where you're plugging it in. You get positive. If you plug in 0, you get a negative answer. If you plug in 2, you get a positive. Okay? Everybody understand those intervals and the signs? All right. So where it's positive, the original's increasing. So from -infinity up to -3, this thing's increasing. And then it increases again from 1 to infinity. It decreases between -3 and 1. And we don't even have a picture of it, but that's what will be the case. What I'd like you to do is take your calculator to verify that. And let's put that original thing in the calculator. Let me go back. Here's the original. So you go to y equals and put in x cubed. If you don't have a calculator, I have some extras. Anybody need one? Okay. You're going to put in x cubed plus 3x squared minus 9x plus 4 in the y equals. And then try a zoom 6 and see if you get a picture of it. And then you want to think about from the left side up to -3, what's the graph doing? Is it increasing? Is it going from left to right? Is it rising? Okay. Between -3 and 1, what's it doing? Decreasing. It's falling. And from 1 on, what's it doing? Increasing. Okay. So that's what we're determining. What is the original function doing based on what we know about the derivative? Okay? Is that cool? We're good? Okay. So that's the example. Let's look at the problems. The first ones are really looking at graphs. So I've got answers up here. You guys have your graphs? Everybody have their sheet for 13.1? Okay. Let's see if we can do this. Okay. All right. This says find the open intervals where this thing is increasing and decreasing. This doesn't have anything to do with doing a derivative on this first one. It's just saying let's look at the graph and make sure we know what increase and decrease is. Well, increase, decrease changes where? Where does it change? Well, but what's the name of that point? Not the number, but what's the name? The min. Okay, so either a max or a min is where it changes. So, well, that's doing it again. I told it not to, and it came back. Okay, so at that point, x is -2. So this thing is increasing from -2 to infinity, and that's what would go in that first box. On MATLAB, that's what you're going to have to put, -2 to infinity. There is a little button that'll give you the infinity sign. And where is it decreasing? On the left, from -infinity to -2. Does that make sense? So we're not doing derivatives right there. We're just looking at it, making sure we understand how to determine what's increase and decrease. All right, same thing here. And what I would suggest you doing, and you can't write on the screen when you're doing it on MATLAB, but you can have a piece of paper there. And I would write down, okay, what are the coordinates of the max? The max is at -4, 3, and the min is at -2, -3. You're only interested in the x values. You're interested in the ones I have in yellow, because that's going to be, it's all about the x when you talk about increase and decrease. So where is this guy increasing? That's a part. It's increasing here. Let's do this. It's increasing here and here. And it's decreasing here. All right, so I did different colors. So it's increasing from -infinity to -4. It's also increasing from -2 to infinity. The yellow is the increase. The blue is where this guy's decreasing, and it's x to x, so it's -4 to -2. Is that good? Make that a little bigger. Okay. Questions on that one? Okay, I think I have to go to the next page. All right. Number 3. List the intervals for which it's increasing and decreasing. So I did the same thing. I color-coded it, and I said, okay, it's decreasing where I have it in yellow, and it's increasing on the blue, and I noted the x values of the max and of the min. It has two mins, -4 and 4, and this one's at x equals 0. And I believe, if it says choose the correct, it may be multiple choice on MATLAB. I'm not sure. But we could write the intervals. It's decreasing from -infinity to -4, and from 0 to 4. It's increasing from -4 to 0, and from 4 to infinity. Is that making sense on the increase, decrease? Same. Okay, now on this one, we actually get to start working. All right, it says find the critical numbers, and then find where it's increasing, find where it's decreasing. So we're going to do that whole process. All right, here's the original equation. First thing that we're going to do is find the derivative. So I found the derivative there, and then I set it equal to 0. Don't want to do that. Okay, and when you set it equal to 0, you end up with 2.8 over 1.9. 1.8, sorry, I'm looking at the wrong thing. But it's easier, and they want fractions. So when you do that, do you know how to change from decimal to fraction on your calculator and all of that? That's what you need to be able to do, because they're going to want fractions. So we have one critical number. Here's your critical number. So we'll draw our little chart, and we have x equals 14/9 in the middle. Define your intervals. On the left of it, it's -infinity to 14/9. On the right of it, it's 14/9 to +infinity. And then we're going to check some numbers. You're not going to be plugging in fractions. You're going to pick whole numbers to plug in. Well, to the left of this, let's pick 0. To the right of it, 14/9 is not quite 2, so we'll pick 2. It's on the right. And when you test those numbers in the derivative, you get a positive and a negative. So where's this guy increasing? Pause in the video. This one. Wherever it's plus, that's where it's increasing. So from -infinity to 14/9, and it's decreasing from 14/9 to infinity. Okay. So the critical number, where's that occurring in the original? Think about it. If that's where the turning point is, what is it in the original? Anybody? If it's increasing and it gets to 14/9 and then it's decreasing, what's happening at 14/9? If it's increasing and then it's decreasing, and here's 14/9, what's that point? A max. It's a max. It is the vertex of that curve. But it's a max. And you want to think about that. That's what you're seeing. Okay, it's increasing, then decreasing. So that critical number is at a max. Does that make sense? As much as it can make at this point? Okay. All right, so that would be all the answers. You would put 14/9 in here. And then you would put the increasing part here and the decreasing part in there. Okay? All right. Did we do, okay, we're on 5. Okay.
Point
Is the point?
in the interval, if you're 0 to infinity,
Mm-hmm.
0 is or is not part of that set?
It's a boundary. It's a boundary. So you get close to it. That's why it's in parentheses. It can't equal that because at that, the derivative is 0. Okay? And that's why you pick a number on either side of it to test, not that number. Okay? All right. Number 5, same idea. We got to take the derivative, find the critical numbers, find where it's increasing and decreasing. So I don't have room there. I'm going to move down to the work. All right. Take the derivative. And this one, we get 36x squared minus 198x minus 108. We're going to set that equal to 0. First thing I'm going to do there is decide, okay, what can I plug in? Factor out. So if I take 18 out of each of those, I'm left with 2x squared minus 11x minus 6. Some of these are not as easy to factor as others. What's the other way? Any of you that are really good with the calculator, if you're trying to find the solutions, what can you do? You can throw it in the y equals, put y2 to be 0, find those intersection points. It would give you 0.5 and 6. So if you can't factor it, if you just give up and can't do it, you could do it on the calculator. All right. So then you have your line. And you have x equals 6, x equals negative 1/2. Define your intervals from negative infinity up to negative 1/2, from negative 1/2 to 6, from 6 to infinity. Pick your test points, and you always want to make that as easy on yourself as you can get. So negative 1's the closest thing that's a whole number. This one we can use 0. This one we can do 7. Okay? When you test those, you'll get a plus, a minus, a plus. Okay?
Those are determined after the test.
Yeah, when you plug negative 1, like if we took negative 1 and we put it in here, I'm going to get a positive 2 and plus 11, so that'll be 13 minus 6 is 7, so that's a positive. If I put in 0, I'm going to end up with a negative 6, so that's negative. If I put in 7, I'm going to get a positive number, so that's where we're getting that. All right, so it's increasing from negative infinity to negative 1/2 there, and from 6 to infinity right there. Increasing, positive, decreasing, negative. And you'll fill those in up there. So you found the critical numbers, we found where it was increasing, we found where it was decreasing. It's the same process over and over again. Questions about the process? Are we okay with that? Okay. We just have to do all that derivative stuff. Oh, number 6. What's number 6? Quotient. Okay. This one's interesting because when you get ready to set it equal to 0, you run into trouble. So you do all of this, you find the derivative, and it's this. You would be able to do that. You know how to do the quotient rule in theory. And we have this. When we set it equal to 0, what happens to that whole bottom? It just goes away. And so you don't get anything. But remember the definition of a critical number. It's where it's equal to 0 or where it doesn't exist. Where can this thing not exist? Not at 0. -2, because it's the only thing that would make the denominator of the fraction go to 0. So, does not exist at -2. So that's your critical number. So if you come up with something like this, you want to look at where would it not exist. -2. From that point, you're doing the same thing. X equals -2. Here's your interval. Here's your interval. Now, we've been used to having them alternate and have some of each. Look what happens. I tested -3 and I tested 0. I got negative and negative. That means this function is decreasing all the time. Okay? So increasing in MATLAB, if it's not increasing at all, you're going to put an N. It's going to tell you that, but just a heads up. So put in an N because it's never increasing. And it's decreasing, instead of saying everywhere, they want you to do this. Okay? Because it doesn't exist at -2. Does that make sense? We're kind of going through this probably a little bit fast, but you will have the video and the notes to look at and kind of go over, and you can pause. Can't pause me real well. All right. Let's look at the last two. Okay, same thing. So you're just doing the same thing over and over again. What rule comes into play here? What's that called? Chain rule. Okay, so the derivative is 4/5 times this, take away 5/5, so that leaves -1/5, and you would multiply by the derivative of the inside, but it happens to be 1. So we have this, and we're going to set it equal to 0. The 4/5 can go away. We can just divide that out. Why did I do this? Why do you think? Okay, so if I write it this way, it's maybe a little bit easier to see. What you can have the square root of 0, but it's going to be where it doesn't exist. So this thing doesn't exist at -3. Does that make sense? Because it's in the denominator and you can see that. So your critical number on this one is -3. And from that point on, same thing. Draw your line, define your intervals, test your points, and you get negative and positive. So where is this thing increasing? Hello. Thank you. -3 to infinity. And where's it decreasing? Thank you. It's really bad on the video when I say that and there's just dead silence. So y'all will hear that tomorrow.
You can't have a negative in a root.
Yeah, but you don't end up with a 0 in the root. I mean, you can't have a negative in it in the real number system, but you end up with -3 plus 3, so it's 0. And you could have a 0 in the root, but you can't have it in the bottom of a fraction. You can't have 0 in the bottom of a fraction. Okay. All right. All right, number 8. What did number 8 say? Was it a word problem? Suppose the total cost is this. Where is this thing decreasing and increasing? So we have a cost function. We're going to do the same thing. We're going to take the derivative of it. So we'll go back down here. So when you take the derivative, you get 3x squared minus 4x plus 6. Set it equal to 0. Get 0.66. It doesn't factor, so you would, what is that? Put that, somebody that's, one of you guys that knows how to do the calculator real quick, put that in the calculator and do it in the y equals and find the x-intercept. Who's going to do that for me? Yeah. 3x squared minus 4x plus 6. Put that in y1 and put y equals 0 in y2. We're just verifying that we can get 0.66 that way.
What do you want in Y2?
0. Have you got it, Liz? Taylor doing it too? Did you get it?
What did you want to know?
Okay, do a second calc 5 and intercept and then enter 1, 2, 3. Okay. That's a quick way to get that answer. Does it just go down and touch at 0.66? So it's a repeated root? I just don't remember what it looks like. Did y'all get it? Did anybody else actually graph it? I asked, but I did not receive. Anybody? The Baylor group? No? Did you get it? Oh.
I get an error, no sign change.
Yeah, I got a no sign.
But did it come down and touch at the x-axis?
I got an error,
No,
so
it's
no sign
well
change.
above the X.
You put
When I-
this one in?
Yeah, when I graphed it, it's above the X-axis.
You put pause. Hold on. Okay. I will actually let you know for sure on that. What you can do is put that one in to the y equals and find the minimum because that's what you need. But I don't know. I have to think about that. So I'll send you a message about that one, about how to do that. You don't have to worry about it too much because you need to study for your test. But we'll go over that one on Monday. You guys study.